This will be the last section I have you do for the year. This is called the Wilcoxon sign rank test. When the samples are independent, as they would be in a before and after test using the same subjects, the Wilcoxon sign rank test can be used in place of the t-test for dependent samples. Again, this test does not require a condition of normality. Table K is used to find the critical values. So, let's look at an example. In a large department store, the owner wishes to see whether the number of shoplifting incidents per day will change if the number of uniformed security officers is doubled. A sample of 7 days before security is increased and 7 days after increase shows the number of shoplifting incidents. Is there enough evidence to support the claim at alpha 0.05 that there is a difference in the number of shoplifting incidents before and after the increase in security? So we got 7, Monday, Tuesday, Wednesday, Thursday, we got the values here. Now our null hypotheses and our alternate hypotheses, that I'm going to go down here, extend the page a little bit. Our null hypothesis, there is no difference. There is no difference in the number of shoplifting incidences. So they're pretty much equal, and the alternate is there is a difference. And this is the claim. So, as we look at this, we have to find our test value. If we went to table K in the back of the book, degrees of freedom would be n equals 7 values, and alpha 0.05 is a two-tailed test. Our critical value here is going to be 2. And now we have to do a chart. The first thing, I'm going to go for this chart and see if I can do this chart right next to it. First thing we're going to do is hopefully draw a straighter line than that, is to find the difference between the two values. So we got 7 minus 5 is 2, negative 1, negative 1, 3, 4, 2, 8. So now we've got those differences done. Now we have to find the absolute value of those. So we had 2, 1, 1, 3, 4, 2, 8. Absolute value of those. Now we're going to rank those. So I'm going to go down here and draw a table, ranking these out in order from smallest to greatest. Putting the numbers down. So we have a 1, a 1, a 2, a 2, 3, 4, 8. So this would be, since these both rank 1 and 2, so this would be a 1.5, 1.5, 3 and 4, 3.5, 3.5, 5, 6, and 7. Those are our ranks. And now what we're going to do is put our ranks back up here next to the values. So the 2 would go with the 3.5. The 1 here would be 1.5 and the 1.5. Then the 3 would be a 5. 4 would be 6. A 2 would be 3.5. And 8 would be 7. And now we have to go back to see what our signs are here and say, okay, we're going to take these ranks and change it according to signs. So this is positive 3.5, negative 1.5, negative 1.5, positive 5, positive 6, positive 3.5, positive 7 on our rings. So once we get done with that, we have to add up, find the sum of the positive rings and sum of the negative rings. So in other words, we're going to go on this chart and add up the positive numbers and add up the negative numbers. So I'm just going to put a little chart down here. Positive numbers added up, negative shouldn't be too hard because it looks like there's only two numbers, negative 1.5 and negative 1.5 is a negative 3. And add up our positive numbers here, we're going to get 11 and 7, 18, 25. So we get positive 25 and negative 3. So select the smaller the absolute value of the sums, which is going to be here is 3, and use this absolute value to test the value, in this case 3. So our test value here is going to use the smaller of these absolute value of these. So absolute value is 3, absolute value 25 is 25. So our test value is going to be 3. Now, is our test value smaller than our critical value? Our test value is greater than our critical value. So hence it is to not reject the null hypothesis. So we're not going to reject the null hypotheses and assume there is no difference. Support the claim that is difference. There's not enough evidence to support the claim there is a difference between those two by having more security on site. Now let's try this. So let's just skip this slide. When n is greater than 30, the normal distribution can be used to approximate the Wilcoxon distribution. So we're not going to use this formula much. Some critical values in table E used for the z-test for specific alpha are used. State the hypotheses, identify the claim, find the critical value k, compute the test value, make the decision, reject the null hypothesis if the test value is less than or equal to the critical value. So here's another one. So we have incorporation of female before and afters. So if we say incorporation of female workers, incorporation of female and male workers were matching according to years experience working for the company. Their salaries were then compared. The data in thousands of dollars are shown on the table. At alpha 0.10, is there a difference in salaries of males and females? So the first thing we're going to do is say our null hypotheses. There is a difference. No difference. Okay, so then we have to find our test value. Now when we get test value before, we have n equals how many values here? 3, 6, 8, 8. At alpha 0.1, table K. Table K here. 2 table K 0.1. First chart, alpha is 8. So 6 is our critical value. So critical value is 6. So now we just set our charts. We're going to subtract before and after, or males and females. So we're going to have a negative 2, or positive 2 here, 5, negative 3, negative 2, 0, negative 1, negative 4, negative 6. Now as we go to, we're going to find the difference, find the absolute value of the difference. I'm going downwards now. Absolute value of the difference here would be 2, 5, 3, 2, 0, 1, 4, 6. And now so we're going to ignore the 0 and put these in order from smallest to biggest. So I'm just going to go over here. We get a 1, we have a 2, we have a 2, we have a 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 7. Yes, right. So this is first. This is 2.5, 2.5, 4, 5, 6, 7 for rankings. So we're going to put the rankings underneath them. So the ranking of this 2 is 2.5. Ranking of 5 is a 6. Ranking of 3 is a 4. 2 is a 2.5. 0 we ignore. 1 is 1. 4 is 5. And 6 is 7. As we go through. So then we look at the rankings. We take these and change them according to signed. So this is a positive, so it'll be positive 2.5, positive 6, negative 4, negative 2.5, negative 1, negative 5, and this is 7 here, so this would be a negative 7. Negative, negative, making sure everything's right here, negative, negative, positive, positive. So my sum of my positives is 8.5, and sum of my negatives is negative 6.5, 7.5, 14.5, negative 19.5. Take the absolute value of both of these. So we get 8.5 and 19.5, and so our test value is going to be 8.5. 8.5 is not less than 6, so we do not reject the null hypotheses, and there is not significant evidence to support the claim that there is no difference between the two salaries. There should be no difference, and there is a difference between the alternate hypotheses. I wrote that wrong. There is no difference. There is a difference. So there support the claim there is a difference. So, and that's kind of how we do it. Now this finishes up the sections. We're not going to cover another section in this. So we're done for the year.